So today's lesson is actually two lessons. We're doing lessons 17 and lesson 18 of Unit 2. And what we're talking about in these two lessons is something called an asymptote, which is a feature of a rational function graph. We talked about yesterday what a rational function is. It's a function that has a fraction in which we have a polynomial in the numerator or the denominator or both. An asymptote is a feature of a rational function graph. An asymptote is a line that gets infinitely close to a function's graph, but does not actually meet the graph. So it gets really, really close, infinitely close, but never actually touches the graph of a rational function. And today we're going to talk about two different types of asymptotes. Vertical asymptotes, so in other words, that line that the graph gets infinitely close to is vertical in nature, and horizontal asymptotes in which that line is horizontal. And I will show you what that looks like on a Desmos graph as I go through the four examples here. So the first two examples are going to be about vertical asymptotes, second two being about horizontal asymptotes. All right, so the first example, we have a rational function of f of x equals 6 over x plus 4. We're going to figure out what the vertical asymptote is. Vertical asymptote, those steps are in the lesson notes. Okay, so set the denominator equal to 0 and solve for x. The vertical asymptote will be the vertical lines at those points. So for example 1, okay, all right, we're going to take the denominator, okay, x plus 4, and we're going to set that equal to 0 and solve for x. Well, this is a pretty simple equation. I can subtract 4 from both sides, and that gives me x equals -4. So the vertical asymptote is a vertical line at x equals -4. So what does that look like graphically? Well, let's look at this Desmos graph here. Here's the graph. The red graph is the graph of the rational function 6 equals x plus 4. The blue graph is the vertical line at x equals -4. And you'll notice if I zoom out, okay, the red graph and the blue graph get really, really close to each other, but they never actually cross each other. That's what an asymptote is. Right? And this is what an asymptote will look like on a graph. All right, so if we do number 2, we do the same thing. Again, take the denominator, 2x minus 2, and set it equal to 0. All right, so I'll add 2 to both sides. So 2x equals 0 plus 2, and then divide both sides by 2, and we end up with x equals 1. Okay, so my vertical asymptote for number 2 is going to be at x equals 1. What does that look like graphically? Here is the graph of number 2. Again, the red graph is the graph of the rational function. The blue graph is the vertical line, that vertical asymptote. And I can keep zooming out. And you'll see that they get infinitely close, but they never actually cross each other. And that's what a asymptote is. All right. So those first two examples are for vertical asymptotes. Okay. The second two examples, number 3 and number 4, are for horizontal asymptotes, and the steps to find those are also in the lesson notes. Okay, this one's a little more tricky. All right, the way we do that is we separate out the fractions and simplify, and I'll explain what that means when I go through the example. Separate out the fractions and simplify. All right, and when we simplify, the constant tells you where the horizontal asymptote is. So let's look at example 3. What do I mean by separate out the fractions? So we have a binomial in the numerator and a monomial in the denominator. All right. And when I say separate out, I literally mean separate out the fractions like this. So I mean separate it out as 120 over x minus 4x over x. That is what I mean by separate out the fractions. Okay. Literally divide both terms of the numerator by the denominator. In this case, the denominator is x. That is a mathematically legal move, right? And if I simplify, well, 120 over x cannot be simplified at all. So I'm going to leave it as that. However, the second part here, okay, I have an x in the numerator and an x in the denominator. Those are going to cancel each other out. And I'm going to left with minus 4 here. Okay, so that is the simplification. And what the lesson notes say is that the constant tells you where the horizontal asymptote is. The constant in this case is -4. So my horizontal asymptote is at -4. And if I look at the graph of this rational function, again, I'll look at the Desmos graph, and we can see I have the red graph as my rational function, the blue graph as my horizontal asymptote. And you can see the graph gets infinitely close to that horizontal line, but never actually crosses it. Okay. So that's number 3. Let's do number 4 the same way. Again, we will separate out the fractions just like we did in number 3. So that will look like this. Okay. So we are going to simplify now. Okay. Now, as far as the first part goes, the only thing we could really simplify is 500 divided by 4. I know that 500 divided by 4 is 125. That x has to stay there. So how did I go from here to here? I just divided 500 divided by 4, got 125, left the x there. The second part, okay, that minus stays there. The second part, there's a couple things I can do. I can cancel out the x's, and I could do -8 divided by 4, which is -2. And that is my simplification, which means my horizontal asymptote is at -2. And if we look at the graph, you can see the same thing happens. Okay? So your cool down today will be just like this. There'll be a couple of finding vertical asymptotes, couple finding horizontal asymptotes. So same concept, just different functions, different numbers.